Hi, my name is Murali, and I'm going to demonstrate how Internet of Things can be used in SAP's HANA Cloud Platform. SAP HANA Cloud Platform is a platform as a service offering from SAP, and one of the key services of this platform is Internet of Things. With HCP IoT services, you can now onboard and manage connected remote devices, get real-time predictive analysis, and optimize business processes at a core of your business. It allows you to quickly develop, deploy, and manage real-time IoT and machine-to-machine applications. For my demonstration, I'm going to be using a Raspberry Pi. The Raspberry Pi is a tiny and affordable computer that you can use to learn programming through fun and practical projects. So it's this green board that you see out here. It's also got few USB slots, which you can use to connect to keyboard or a mouse. It's got an Ethernet connection, audio and a camera output, HDMI output, which I'm using to connect to my monitor. This is the power output, and on the left hand side you have a series of pins out here. They're called GPIO pins, general purpose input output pins, which enable the communication with outside world through sensors. So towards the left I've got a breadboard, and I have actually purchased two sensors. One is a photo sensor, and the photo sensor is out here, and this one that you see out here is the temperature sensor. So as explained in the blog, I've just followed the tutorial in the Adafruit website and set up this configuration based on what was mentioned out there. And you can see for the photo sensor, I have also attached a capacitor, and for the temperature sensor I've attached a resistor. And now with this, the configuration on the breadboard is complete. So here is a Python script which will read the sensor values from the GPIO pins and post the messages to HCP IoT services. As mentioned in the blog, HCP IoT services currently support two different protocols, one being HTTP and the other being WebSockets. I've used both these protocols in this particular script, which I will also make available as part of this blog. On the other hand, I have also created an application which I have hosted on HCP, and you can see that it has a couple of gauges out here, one for the temperature and the other for light, and it also has a map which shows where the device is currently. What I'm going to do is now quickly run this particular Python script from the terminal, and this will initiate a connection with the sensors and try and get some readings out. So I can see that it's already starting to get information out of the photo sensor and the temperature sensor, and it's going to post it to HCP, and they get a feedback from the HCP IoT service that the message is received from the device which has been registered. Now if you move over to the application, you'll be able to see that the gauge is changing accordingly to based on the information that we're getting out of the sensors. The temperature that you see in the temperature gauge just reflects the current room temperature. What I'm going to try and do is now put my hand on top of the photo sensor and then just wait to see what happens. So you can see now that the sensitivity has dropped, and now it reflects to 54. And if I get my hand off, it's again going to go up all the way to 200. So this is a good example that shows in real time how information from your sensors can be streamed all the way to the HCP. In the beginning of the blog, I mentioned that I was motivated to do a prototype as a result of a discussion with one of our customers who are leaders in rail freight. They were keen to understand how they could use HCP to provide a solution to their partners, who could in turn monitor the trains in real time based on sensor data captured from devices installed in each wagon. I wanted to get something which is easy to install and small in size, hence I decided to just get away with the breadboard completely and instead use a sensor tag. So this little thing that you see here is a sensor tag, and it's got about a dozen inbuilt sensors and can use Bluetooth to stream the data all the way to the Raspberry Pi. So I used a couple of Node.js libraries which are available. So I had to install them onto the Raspberry Pi to get the sensor tag to stream the data all the way to the Raspberry Pi. So to get the prototype working, I just borrowed a toy from my son, and I'm going to now hook up this sensor tag to one of the carriages, but before that let me switch it on. So there you go. I'm going to nicely place that in. This is the Node.js script which I'm using to hook up with my sensor tag and read the values from different sensors which are available. I'm going to now open the terminal and execute this particular script. All this does is initiates a connection with the sensor tag and tries to obtain values from different sensors. So there you go. The temperature being recorded as 27 degrees, humidity as 55%, and a light sensitivity as 36. Now if I move on to the HCP application, you can see it's obtaining this information real time from the sensor tag. Now the best way to test this is to remove the lid from the last wagon, so thereby I'm going to expose more light into the last wagon. And also I want to increase the temperature by using a hairdryer. So I'm just going to put the hairdryer onto the last wagon now. And now if I look at the application, you can see that the temperature has gone up and also the light sensitivity has gone up to 196. I just want to use the train as a prototype to demonstrate this example, but this can be practically used in any sort of industry, be it manufacturing or retail. There is a use case for all of them. I hope you enjoyed watching this video. Thanks.